Hello, this is Jason Dufair, and I'm going to go over my final project here for CS6476 and talk about the trials and tribulations of putting together a convolutional neural network for image recognition. And let's be honest, it's mostly tribulations. Okay, so what I wanted to try was, given that we were classifying 10 digits, I wanted to find out what the ratio of digit to non-digit data how the ratio of digit to non-digit data would affect the models that I create, both custom and the two versions of VGG16. So my pipeline, just to go over my pipeline real quick, I collected the data from Stanford for the images. I found a CSV that had the bounding boxes, so I didn't have to mess around with parsing H5 data. And what I did was I used the suggestions in the Goodfellow paper to crop the images to their bounding boxes, 30% larger than their bounding boxes, and then take a random 54 by 54 sample of that. Talking about stochastic gradient descent there, what I finally did was run essentially 9 trials, and those included 3 trials of my own custom model, one with 9% of non-image data, which basically means 9 digits each at 9% and a 9% bucket with random samples of other images. 18%, well, where we basically double that non-image, and then 50-50, where 50% of the entire training set was image data and 50% was, again, random samples from images. I had some success with that after struggling a little bit with which optimizer to use. I started with Atom and found it to be pretty ineffective for what I was doing, at least with the different learning rates and things that I tried. I went to the basic stochastic gradient descent optimizer, and I had some success, but mostly it couldn't find very many digits, even though in the 9% scenario, you can see the accuracies and losses were fairly reasonable. So I had a little bit of success. VGG16, where I trained the model from scratch, I couldn't get it to converge at all. So I tried various sets of hyperparameters and didn't really have a lot of luck. Would have loved to have tried some more of that. The VGG16 with the pre-trained model, I built my own fully connected layers. And as you can see, the accuracy is great, both in the 50 and the 9% range. And the losses were pretty reasonable as well. You can see that there was some decent amount of numeric recognition and a few false positives. So much more to learn, but it was a great project and I learned a great deal in the process. I look forward to doing more. Thank you.